Good evening, Titans. And today we're going to be starting our unit number 5, and we'll go over lessons 1.4 and 1.5 this evening. Hope your test went well today over unit 4, and again, we're moving on to unit 5. So the first of the objectives we're going to discuss will be to understand the coordinate plane and how to plot ordered pairs, and then find solutions to a linear equation with two variables. First of all, the coordinate plane. Okay, the coordinate plane is formed by two number lines called axes. They intersect at a right angle. We have our x-axis, which goes on the horizontal, and you have your y-axis. Where those 2 points meet is called the origin. So that point right there in the middle is called the origin. And when these two axes intersect at the origin, they form 4 parts, and these are called quadrants. So here we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And they're numbered in that way. The reason they're numbered that way is that in quadrant 1, both the x-axis, or the x-coordinate, and a y-coordinate are positive in that. So that's why that one starts out as quadrant 1, and then we just go in a counterclockwise manner to number them 1, 2, 3, 4. And then an ordered pair corresponds to every point on this axis, on this coordinate plane. And so there's one ordered pair that's plotted here called 2, 1. And so the first coordinate of an ordered pair is always the x-coordinate, which means I move along the x-axis left or right first. And then the second coordinate is the y-coordinate. And they're called an ordered pair because they're always in this order, x followed by y, meaning the horizontal movement followed by the vertical movement. So for the ordered pair 2, 1, we go 2 to the right and 1 up, and then that would be our ordered pair, 2, 1. So you can think of graphing ordered pairs sometimes as climbing a ladder, and the fact that when you have an ordered pair, say 2, 3, it is helpful to think of how to use a ladder. You always have to decide where to put the ladder on the ground before you can climb it. The same is true with ordered pairs. The first number tells you where to go on the x-axis, or the ground, and the second number tells you where to go on the y-axis, or how high to climb the ladder. So the ground is the x-axis, and the height is the y-axis. So one of the things you'll be asked to do is to graph ordered pairs, obviously, but here is a problem where you'll be asked to determine if the 3 points lie on the same line. They use the word collinear, and the word collinear means that the points lie on the same line. So we're going to graph 3 points here, and we're reviewing each time. So coordinate A, or point A, is 3 to the left and 2 up. So there's coordinate A. So again, we graph the x-coordinate, we graph the y, we graph that point, and then we label it. Point B is 3 to the right and then 4 up. And there's point B. And now point C is -5 and then -6, so down 6. And point C. So if I were to draw a straight line, could I make a straight line go through all 3 points? And so obviously no, you cannot have a line that would go through all 3 points. So for this question, the answer would be no, that they are not collinear. The next objective we want to discuss in Unit 4, or Lesson 1.4, is they're going to give you 5 values, and so they give you 1, 2, 3, 4, and 5, and they give you this equation that has both an x and a y in it. Well, the values given to you are your x coordinates, and you have to substitute them in for the x, and then what you get out is the y. So We plug 1 in, 1 plus 1 is 2. We plug 2 in, 2 plus 1 is 3. We plug 3 in, 3 plus 1 is 4. We plug 4 in, 4 plus 1 is 5. And plug 5 in, 5 plus 1 is 6. So here's the table of values this way. They're also ordered pairs though, 1, 2, 2, 3. This one is 3, 4, and so on. So all you're doing is finding the ordered pairs that would make that equation true. So we have another example here. Again, you're going to plug in 1. So I have 2 times 1 minus 5. So that's 2 minus 5 is a negative 3. I'm going to plug 2 in. Now, 2 times 2 is 4. 4 minus 5 would be a negative 1. Now I'm going to plug 3 in. So now 2 times 3 is 6, and 6 minus 5 is 1. I plug 4 in. 2 times 4 is 8. 8 minus 5 is 3. Plug 5 in. 2 times 5 is 10, and 10 minus 5 is 5. And again, this is a table of values, but they're also ordered pairs. And we could graph these. And if we would graph these, you'd see that they lie all on the same line. Now the second part of what we're going to discuss again today comes from lesson 1.5. And we're going to represent linear patterns with equations and then represent linear equations with graphs. A couple definitions here, so you may want to pause here and write this down. But we have the independent variable, and the independent variable means that it's the x value and it's a value that you choose. It's independent. Then the dependent variable is the y value. And when we have an equation, say y equals 2x plus 3, the value I plug in for x is the independent variable. I'm choosing that value. And the value I get out, which is the y value, depends on the value I plug in for x. So that's why the independent variable is the x and the dependent variable is the y. And then linear equations, they're called linear equations because when we graph them, they form a straight line. So we said we're going to represent linear equations from problems that deal with linear data. And so here's just an example. It says a small cheese pizza costs $8 and each additional topping costs $1. So more or less, you have an initial cost of $8. So you have 0 toppings on there except for the cheese, and it costs you $8. Well, if I choose 1 topping, it's $1 more. If I choose 2 toppings, it's another $1. And so it's increasing by 1 each time. So the number of toppings multiplied by 1. So this cost is 1 times the number of toppings plus 8. But since again we don't need to have the 1, we just write it as C is equal to N plus 8. So here's another example. It says, again, we will write the equation in the form y equals mx plus b, where m is going to be called our rate of change, and that's going to be the variable cost. And that's determined by how much is y changing compared to how much x is changing. And then b is the value of y when x is 0, or a lot of times what we call the initial cost. So we first have to do this by finding the first differences. So that's 13, this is 13, this is 13, this is 13, and this is 13. And since the x values are only increasing by 1 each time, then we know that our rate of change, or m, is equal to 13. And so our initial equation is y equals 13x. Now, the value of y when x is 0 is 26. So I need to plug in or have 26 as my b. And now I check this. If I plug in 1, 13 times 1 is 13, plus 26 is 39, and it checks. And I could check it for all of them. So there's my equation for that linear pattern. Again, here's just another example. It says the cost associated with being a member of the Railroad Comic Book Club is represented in the table below. Find the first differences and write an equation to represent the data pattern. Well, this is 3, 3, 3, and 3. And as you notice, the x's are increasing only by 1 each time as well. So we can use variables that make sense to us. So in this case, the cost, the variable rate, which means the value I'm going to multiply by the variable, so by the number of comic books, so 3b, and then the value of the cost when b is 0 is 18. And there's my equation. So I've represented this by this equation where, again, 18 is your initial fee to join the club, and that's $3 per comic book. So our equation is C is equal to 3B plus 18. Alright, I'm going to just do the second one here since we're going long on time here, and we're subtracting in this case 396 minus 362 is 34, and then we come here and that's another 34. This is another 34. Here's another 34. And so the variable rate, again, as these are increasing by 1 each time, is that it's a negative 34. So I'm going to have y equals a negative 34 times x. Again, this rate of change is always multiplied by the variable, and then the value of y when x is 0 is what's at the end. So this could represent maybe you have $396 in the bank and you're going to take $34 out a month for spending money. Now, the last example here we want to go with is you're going to have to graph, and again we're going to use a table of values here. And they're telling us we're going to plug in 1, 2, 3, 4, and 5. If I plug in 1, I get 175 minus 20 would be 155. If I plug in 2, that's going to be 40, and so 175 minus 40 is 135. And I'm going to subtract 20 again, so that's going to go down to 115. And since I'm going up by ones, I know this is going to go to 95, and this is going to go to 75. Now the hardest part about graphing these is doing your scale. Again, this is going to be 0, 1, 2, 3, 4, 5. But I can have a different scale for my y-axis. And since we want to go all the way up to 175, we're going to go maybe by 25. So I'm going to go 25, 50, 75, 100, 125, 150, 175, 200. And so now I'm ready to graph. When I plug 0 in, I'd have 175. Plug 1 in, I said I'd have 155, so that's going to be a little bit up there. 2, I get 135. And again, notice how I'm just placing them where I think they should go. 3, I have 115. 4 would be 95. And 5 would be 75. And you notice this forms a straight line. And so that's the last concept that we're going to discuss today, is just being able to graph linear equations by using a table of values. And again, this not all of them, you're going to have different scales for the x-axis and the y-axis. But in order to fit this on, we wanted to make sure that we fit the x-axis went by ones, and the y-axis, in this case, I went by 25s. I could have gone maybe by 15s, could have went by 10s, but something so I don't have to use a full piece of graph paper in order to do it. Now, I know this was a long video tonight, but it did cover 2 lessons, and we'll be ready to get after things tomorrow and reviewing these concepts in class tomorrow. So enjoy the rest of your evening, Titans, and be ready to get after it tomorrow. please make sure you fill out the Google Doc after this.
Made with Doodlecast Pro.